Okay. Let's check webcam. We're not connected. There we are. Hello again. Welcome back. It's good to be back. Make sure we're all set up here. So yeah, welcome to the stream. I'm Agent Ultra, and this is where we hack on Haskell once a week, usually on Tuesday evenings, and learn a few things. So we're building an Asteroids clone in Haskell. We've been doing this for a while now, and I think we're getting really close to the end. And so let's get some tonight. I believe we were working on updating the input handling so that we could better support our menu system and stuff. So I'm going to open up my Asteroids project, go to game. Here we are. So if you want to remember what the game looks like, or this is your first time tuning in, let's get our project building. We'll do fast with our file watcher. Wait, what did I do wrong here? Oh, I did just dash file watch. It should be dash dash. That's better. Yeah, so we'll get that building and then we'll run it. I think I have it in my history. There we go. Big arrow. All right, so we have the menu kind of working, but it's like super fast. And it's because we've got key repeat happening and we're not filtering out those key repeat events at the moment. So we're getting a key down like every frame, even when we're holding it down. Right, we only want the key down event to be triggered once, and if it's a repeat, let's not do anything about that. And then we have to add the actual like menu selection type stuff to this little menu widget that we built. But otherwise, we're gonna get that done. So I did a little digging around. I think what's going on here is the SDL API. So in SDL 1.2, you used to have to turn on key repeat with an API call. Now, I think the way SDL 2 works is that it just always sends the key press events no matter what. And it has this repeat field. And the repeat field is like basically the way you can filter out the events. So if you don't care about the key repeats, you just ignore them and you're going to get sent them no matter what. So I think that's all we got to do. And if we filter on that repeat field, I think it might change a little. Actually, our button handling might be fine with it with us filtering out, but we'll see. We'll see. So I just have to make sure. We just have to make sure that the Haskell bindings we have also have this field wrapped. Look up the documentation here. Some reason the documentation there. Keyboard. And let's check for repeat. No repeat there. Let's see. Let's see. If we don't have that, then we have to do something else about this. Maybe it's not on keyboard input. Maybe it's on event. Oh no. It can't. Oh no. Don't tell me it doesn't have it. That would be not good. Keyboard state. Oh no. I don't like this. Repeat. No repeat. Some type patterns for scan codes, but I'm not seeing repeat. Keyboard event, where are you? Why aren't you wrapped? Maybe it's at a lower level. Tell me they've wrapped this. Struct. Let's get event filter, flush events, filter events. Storage associated with the resulting function pointer has to be released with free Haskell func pointer and is no longer required. There we go. This looks promising. There it is. Okay. Sweet. Oh, thank goodness. Okay, so we have the raw Haskell struct record wrapping the struct under event. And then we can get keyboard event repeat. Sweet. I'm kind of curious about these filters. That seems neat. Event filter. So if I create an event filter, STL filter events. Okay, so set event filter. We can set up a filter to process all events before they change the internal state and opposed to the queue. Hmm. Okay, well, we can filter in Haskell and see what happens. And then maybe we can try this if it's no bueno. So all that matters is that we can get that event record. So these events and then is keyboard key. Yeah, so that's our SDL event record. We could filter here. And the function is keyboard. Keyboard. Event repeat. There we go. And then we can go not. Okay, and we got a type error here, so this couldn't match. We expected event data, but we got event. Okay, no problem. So we need keyboard event as the function there. Oh, we have that in scope. Keyboard event, like that. Okay, now hopefully, we're still getting quite fast. Repeating. I don't even know how that works. How's that compiling exactly? That's a word 8. Not takes a bool. Weird. I want to check that out. How can I make a word 8? Huh. Let's make X be a import data.word. I think we have to do that. Yeah. And we might have to set scope to type variables. And we'll make x be a word 8. Okay. Yeah, that shouldn't compile at all. Oh, this is the higher level version of the function. Okay, that's not the raw one. Where I thought I was using the raw one. I guess there's a higher level one. So that one does return a bool. Okay, so it's a keyboard key. If it's a keyboard event, then the term is that if the keyboard event motion of the keyboard event is key state, and key state is an input motion, or key down, and the keysim key code is the key event we're looking for, and it's not a repeat. Okay. Maybe this isn't the right place that we're filtering that. Let's go to our button handling stuff. We're getting the events. So this is where we're using is keyboard key. Oh, I see. I see. Maybe it's because we're using any here. No, that should be fine. Any non-repeating is Q press would be a Q press, or any non-repeating is a press from events. No, we don't want that. Okay, and so we check if W is pressed and if W is up. If it's pressed and the key release, and I always get the up event. If the last state was W pressed, oh no, this one. Okay. Ah, okay. So if this frame, W is pressed, and the last frame in our game state is key release. Then we switch it to key down, right? And then if this state is button up, and the last was key down, then now it's key release. Otherwise, it stays the same. Okay. Okay. It becomes the new button state, which we set up here. Okay. So then, why? should be working. Maybe I was too fast on the... No. We're still getting a... Let's check our game logic. Maybe it's our game logic. So our scene logic for this should check if... Should only react when it's down. Or when it changes. So where's our menu scene? So we call menu down. This is our menu handling code. Okay, that's all fine. Menu state, menu up, menu down, menu select, blah, blah, blah. So what might be happening is that that's all fine. We're not getting the key. We are filtering on the keyboard. Repeat, but our menu update, there we go, is checking, is maybe not guarded, and is updating every scene. So main menu update says if the key down, button state down of the game state button state. So every frame, if this button is held down, it's going to do this. That's probably where the issue is. We just need to know if it changed, or if button was pressed this frame, but not held. Yeah. Okay, so. We should have so that this button state only checks if it's currently held or if it's currently released. And by the time the main scene gets a hold of it, we have already updated the button state. Yeah. So we can have, we can add maybe fields to check what the, or we, yeah, we could have a field to check, we could have a field that like a flag that checks that this button was pressed this frame, that we clear out every frame. And that way we can just tell if it was pressed this once. We don't really care if it's held down, we just want to know if it was pressed. And that way the update code just has to check that flag for this scene. The other thing we can do is we can retain the button state from the previous frame and check for the difference between the two. So then this button state here that we calculate becomes like the next state, and then at the end, after we're done all our updates, we make that new state the last state before we loop. I'm not sure which one I like better. Which one would be more useful in this case. And I don't want to add a third state to button enumeration, I don't think. Because that'll have to update all of our button handling logic for that third state, I think. There might be a way to do it, though. Okay, why don't we try that first and see how that goes. Key state. So we can have a key pressed state. Yeah, so then our semi-group of key state becomes a whole another beast. Slippy Goat, thanks for coming in. Yeah, I definitely could. Oh no, that's cool. I totally should, because like that's the whole point. Thanks for pointing that out. I just have to remember how to do that on Emacs. Blah blah. No. Otherwise, I'm just going to make it bigger for this buffer. Hopefully that's good enough. Control Shift Meta Escape Plus, something like that. I don't know. I always have to look it up because like there's just so much stuff up here that I forget. Yes, so I am using SDL, and I'm not using a ton of Haskell libraries on top. So we're making an Asteroids clone, and the goal is partly, well, we have actually most of the game working. We're actually just working on the main menu. So I can't show you the rest of the game yet until I fix this. But the goal is to work on like practical level like Haskell projects, like something working and bigger than like Hello World. Like we're not learning how to write a function or like what a type is necessarily, although we do talk about those things sometimes. And yeah, I was kind of curious about seeing what the state of Haskell is for game development, and is it viable for making like arcade style games. And so we're pretty good so far. We're not using a whole lot of Haskell libraries, like I was saying. We're using pretty raw, pretty vanilla Haskell type, at least on the Haskell side of things. Yeah, no lenses. We're not using any effect libraries or not even monad transformers or anything. Nothing fresh out of some paper, nope. So we're doing this in like super duper like low level Haskell. Just as like kind of a first pass prototype type of thing. Cool. Nice. Yeah, when I was learning a lot of functional programming, experimenting with pure functional programming languages or like dedicated functional programming languages, I actually started with OCaml and did the course through INRIA when they did the interactive one. That was pretty cool. Well then, let the dulcimer tones of my voice carry you off to a magical place. Sleepy goat. Okay, so like I was saying, where were we? We were talking about button states. Yes, and the semigroup instance for our key state now is kind of more complex because we added a third if we want to add a key pressed state here. Now the combinations here is going to be 3 to the power of 2. It's going to be a lot. So I might not want to do that. It sounds like a bad plan. It smells stinky. So if we want to do this with a flag, let's look at our button state. Maybe we could just add button state up pressed, and it'll just be a Boolean. And we'll do the same for button state down. And button state left. Right. And fire. Okay, so we have to set the init button state for all of those. I'm just going to copy this. Up pressed. And initially it'll be false. And left pressed. Right pressed. And fire pressed. Okay. So that should all compile and work, I think, still. But we're not doing anything with it yet. Okay, so now we're going to go back to our button handling code. Okay, and now where we create the new button states. This is where we need to set the Boolean flag of whether it was pressed this frame or not. If our plan works, this will be nice and easy code, and it'll fit nicely into our framework. If it's garbage, it'll be annoying and hard and soul crushing, and we should stop at that point. So we'll add them here because I don't know what the terms are going to be yet. Okay, so currently in scope here in this hole, we have to return a bool. And the things we have in scope are the all of these, whether this was pressed or not. A pressed is a bool. Good, good. That'll be enough. We have it in scope already. So is up pressed, that's just W pressed. Is down pressed, that's just S pressed. Left pressed is A pressed. D pressed. Fire button, fire pressed. Space pressed. Okay, that was pretty easy. Feeling good so far. And then the next thing we need to do is we need to make sure that after we're done our updates and before carrying the loop over to the next state, we reset those flags back to false. That might be a little paranoid, but I think that'll be a little... Well, let's just test it out and see if that's good enough. But I'm pretty sure we'll have to do that. Yeah. Okay. Oh, we're not reacting to that yet, actually, so I don't know 100%. I'm going to add it here anyway. If we don't need it, we should just be able to delete the code, and that's not a problem. Since we're here, we might as well just do it. And I'll do that by game state, button state, reset pressed flags. And I think something like that. That's probably what I want to write. Now I have to go implement reset pressed flags, but that should be easy enough. Okay, let's go add that. That should be button state to button state. Little goo buttons. Yeah. We'll do buttons, and we'll use our record update syntax. Pretty straightforward stuff. And we'll go button state, up, pressed, false. Down, pressed, false, left, pressed, false, right pressed, false, and fire pressed. Let's pull that over to the left a little bit. Just line those up. Okay, so we just have a little error here. We just need to fix game state, button state. Oh, Oh, because maybe we're using record wildcards in this scope. Must be. Okay, successful build. Let's, okay, awesome. Much better. Yes, so now I have to tap my button to get there. I can't just hold it down and keep in, it's not repeating infinitely now. Wonderful. So the next thing to implement in our main scene, let's look at our code. Actually, let's commit this first, and then we'll finish up the main scene. Actually, looking at this, I'm kind of a little bit surprised that this is working. Only because we didn't update the main scene to check for the pressed flag. It's weird. Okay, I'll make sure I'm actually focused on the right thing. I think, yeah. Well, that's behaving right. A little surprised. Why am I surprised? All right, we added just the flags, booleans, to a record. We initialized them all to false. We reset them. The loop, we changed the loop, the state we passed into the loop, where we just reset the pressed flags back to false. We added the filter there to the isKeyboardKey so that we're not checking the keyboard event repeat flag on the event struct there, the keyboard event struct. Nothing about the menu code has changed. But we were a little confused earlier when we started filtering for the repeat flag that it wasn't having the desired behavior, which is why we added these Boolean flags. Actually, I wonder if it was this line here that did it, oddly enough. When we change this line here, game state, button state in this scope is the button state from the last frame. Because we're using record wildcards here to pull that out. And yeah, button state prime is being passed in to run scene. And that's why it seems like it's working, I think. Because when we pass in button state prime here, we are calculating the next state of the buttons based off of the last frame. And then when we do reset flags from the old state, it's going back to its original state. So it's just going back to the init state every time. So it looks like it's working because it's behaving like the way we want it to behave, in that it's detecting the change, the button was pressed this frame, and then is the next update through our loop, it's going back to that first state again and calculating the button states off of the initial state. So that's kind of funny. That won't work. I don't think that'll work for our game when we actually run it, but it works for the menu. That's weird. That's interesting, but that worked. Not terribly obvious, but yeah. Hmm. Okay. Let's see if we can just, let's keep that bug in mind and see if it's actually a bug, or if maybe it's a feature and we should keep it. I'm just going to call it with WTF button handling, question mark. And get back to the main menu update. Okay, so that handles up and down. Let's add another guard for fire pressed. So if the key down is button state fired of the game state, button state. We're going to either, well, we have two options, quit or start the game for now. So we have to know which menu item we're on. And then change the game scene if we want to start the game, or just quit. Okay. So our menu state, I think we had that. Oh, we implemented that function. Menu choice. Okay. So we get either, when we choose it, we either get start or quit from menu choice. And yeah, and then we just add pattern match on the menu choice and do the right thing. Cool. So game choice, we need game state, menu state. Game state main menu. Yeah. That's the one. And either start or quit. Oh, menu select, sorry, menu select. Okay. Okay, so if we start, and then we're going to return games. We have to return a game state here. So return game state where the game state scene. It's going to be a scene, and we have main scene. Quit. Quit. We're going to have to do something with that. We're going to have to, I'm just checking if I have implemented a flag in our game state to tell the game loop to quit. We have render, ticks, current time, accumulator, player shift button state. Doesn't look like it. Okay. So handling quitting, we're going to have to, we'll just not do anything in that case for now, and then we'll implement quitting in the next change. Let's just see if start works. Cool. Rebuilt. Let's run. And there we go. Cool. Oh no. Okay, yeah. So our bug is our bug. Unfortunately. I actually have to like tap. I'm tapping the key to increase the speed here, tapping to turn. So that's no good. We'll have to fix that, but that works. So, so now I'm getting my changes a little bit mixed up here. Let us commit this. This will be fine. And then we'll fix the button handling. Yeah. I'm going to mark this as work in progress, so we remember to not commit. Hopefully I remember not to push this. Add main menu select. Start game. Okay. So buttons, buttons. So yes, the main menu needs to react to the button state, and we also have to pass in the proper button state to the loop so it doesn't reset back. So this should be button state prime, I think. And once that it'll break the menu temporarily, but if we can get it to start the game, that should bring the game back to the way it was. Yeah, so that's better. That's good. And now we just need to update the menu handling code to inspect the flags instead of the key down state. So we don't want button state down. We want button state down pressed. We don't want key down of the button state. We want button state up pressed. And here, we don't want key down. We want button state fire pressed. Okay. On this change, I think this will work. This will get us our tap to our click to change menu, fire to start, and then in here, yeah, we're golden. Cool. And then there's our asteroid spawning. We're doing well. Booyah. Okay, let's fix that and commit that. Do. Okay. We'll rebase this. Squash that in and revert that one. Okay, we are going to call this command add our key pressed state. Allows us to detect the event was fired and not the current, instead of the current state of the key. Now this allows us to detect that was fired so that the menu input handling can work properly. Okay, let's make quit work. We're gonna need to add a little flag there, I think, to our game state. Oh, game status. That might be good. I think I'm gonna remove game status because like I was thinking of using that as like the enumeration of like what state the game is currently in, but we're kind of using scenes for that. Although we might need to leave it in because there's no way to compare scenes. So if we wanted to know which scene we're in, we wouldn't be able to query that without this enumeration. So game status might be one way we could do it. We could add a new case here. That we could check for at the end of the loop and quit out. Okay, so we'll add that, and then when we pattern match on quit, we'll do game state where game state status equals should quit. And then in loop, so unless Q pressed or game state status is equal to should quit, And then we should be able to quit, press fire, and we quit out. There we go. Move there, and everything's good there. So commit that as well. That kind of gives us the opportunity to clean up a little bit of the, well, it's not, maybe not necessarily clean up, but it's kind of useful. Maybe you should keep it. Right now we kind of have like Q is like hard coded as like an easy way to quit from pretty much anywhere in the game when it's running. All right. We just check if Q's pressed. Yeah, we could clean that up and make it like only the game state status should quit would do it. Yeah. I don't know. I think it's fine. Whatever. Okay, so we have the menus done. We have the game over screen done. We have the score timer. We have our ship. We have the bullets going off and all the collisions happening that we want to have happen. Yeah, maybe we should work on sound. No game should be silent unless that's the intention you have in your art. And you want to make a silent game like the old-timey people used to do in the golden days of games. Yeah, we could probably do sounds. That would be nice. And then maybe just a little bit of polish, make things look nice, and call it a day. Oh, and we also do like we should do some performance profiling maybe, and like checking just to make sure that everything's going to run pretty well. And probably the last bit of the project is just getting like multiple platform builds going, like a Linux release and a Windows release, for example, and that would be really nice. Maybe Mac, I guess. But I don't have a Mac to test on anymore, so I don't know how I'm going to do that. However, actually, no, that's not true. I have ways. Anywho's, let's do sounds. How are we going to do sounds? SDL library for sound. SDL mixer, I think, is the one library, right? Okay, normally it's another C library that you kind of have to like link in your own project if you're going to be doing that. I'm hoping we probably have one in Haskell. And we do. Super dope. Okay, audio setup. Cool. So you got all your samples set up, formats, outputs. Okay. There's our loading audio data. two types, it looks like chunk and music. So music is played on a separate channel, usually, yeah, different from the normal mixing channels. Cool, cool. Chunks are played on channels, which can combine into groups. Super duper. I don't think we're going to need a whole lot of channels. If we decide to do a music track, we can do a channel for that, and we can do a channel for SFX. Maybe we do... we could probably have like a couple of channels, you know, one for the ship effects and one for the collisions. Okay, so we create channels. Play a chunk once, using the first available channel. Cool. Yeah, I don't think we're going to need more than 8, that's for sure. So, all right. So then we just need some files. We need this library, and then we're good to go. Okay. Let's add it to our package. SDL2 mixer. And it's not in our stack build, so we're going to add this. And then we're probably going to have to add the dev libraries to our development environment. Install. What's the library called? SDL. I'll just search for it. Search. Mixer. Oh no, looks like that's 1.2. There we go. SDL2, mixer dev. The build on Haskell probably failed because we didn't have the library in there when it was configuring. Yeah, it looks fine now. Okay, so while that's going, let's get a helpful little program. I wonder if it's in the libraries SFXer. No, okay. Okay, might have to pause the music while we do this. This is a handy little utility for just making little sounds. Let's start with like the laser shot. That was pretty good. Yeah. That's cute. I like it. Okay, that's our sample. Let's download that. Okay. More. Laser shoot. Okay, we'll put it in. So we'll make a directory. And we'll call sounds. Assets. And we'll move laser shoot into it. Okay. Cool. So that's where will be our laser sound. Next thing to get this to go is to load our sound into a chunk. So when we run, this is where we do all of our initializations. We have to initialize the library and get a chunk and put our chunk somewhere where we can access it so we can play it later. So we'll put it in the game state somewhere. So it's kind of like pretty gross and dirty. We're just like throwing stuff in the game state, whatever. But for a bigger game, obviously, we'd probably have like some kind of map or something that we could use to organize these a little better. But it's fine. It's fine the way it is here. It's just such a small game. We don't need a framework or anything like that when we're making asteroids. Just do what you gotta do. Make the first thing that works work. Let's turn our music back on for now. Okay, and yeah, so let's import the SDL mixer library. For qualified SDL.mixer as mixer. Super de-duper. So we have to call with audio. MA to MA. We have to call SDL itself with init audio. Okay, so let's go to run. So we initialize everything. So that should be with init audio. So to give us some configuration, audio and chunk size. And then wrap it around some MA. Probably like this. Mixer.with audio, sorry, yes. Okay, so we need an audio to pass to that and chunk size. Okay, do we have a default chunk size? It's just int. An alternative to with audio also initializes it. Yeah, actually, we could probably just do open audio since we do that with the font library and stuff. Open audio. Chunk size. And then mixer close audio. Okay, back to chunk size. Okay, what's a good chunk size? Okay, we got default audio, so we can just plunk that in there. Mixer dot. Then we just need something for chunk size. That's all the advice it has for us. Don't make it too big, but don't make it too small. Okay, like what's good generally? Let's say 1024. It's probably pretty good. Okay, everything compiles again, so we're good there. Now we need to get a chunk from our audio file. Loading audio data. Okay. Load file path MA. Sounds good. Okay, okay. Let us pull in those types from Mixer. Chunk, at least, for now. And we'll put it in the game state. Okay, bullet timer, bullet age, Mac, blah, blah, blah. We'll do game state, bullet, sound, chunk. And then when we go to init the game states, we're going to need that. Yeah, font. We'll put chunk over here on the end. Why not? Game state, bullet sound. Yeah. And then in a game state here, so we need to have something in scope to give there. Let's call it bullet sound. Okay, and then we have load, I think is the function, and a file path. Mixer.load, just like the font library, that's pretty nice. Laser sound, dot wave. Okay, we compile. Cool. So everything should just run as before. And, well, except we're getting some errors, which is fine. Okay, that's good. Oh, this isn't going to work on my system because I don't have audio set up here in my VM. Rats, friends, rats. We have graphics, but we have no audio. Is there a quick and easy way to make this work? Audio in Linux WSL2. Okay. We gotta get pulse audio for Windows. Configure pulse audio for Windows. Configure pulse audio for NWSL2. Ooh, okay. I'm going to make this happen off stream. And we'll get that working next week. So let's stash these changes here. Stage that, stage all this. Add sounds. Okay. Okay, so we'll get sounds working next week just so we can play them on the stream. But so far, like, the code's looking good and fine, and that's nice. What else do we need to do? We could probably tweak the... We don't have a ton of time left on the stream, but we could probably tweak the game a little bit. The gameplay. So the max number of bullets. I'm not super happy with that. It seems like either we have to spawn a ludicrous number of asteroids to keep it interesting, which we're already kind of doing as we have that whole scaling thing going on, or we need to limit the number of bullets you can have. Max bullets. Let's take that down a snitch. Let's take it down to 5. Okay, a little better. We can take down the fire rate a little bit and increase the bullet age. Max bullets, bullet age max, yeah. Yeah, game state, bullet. 50, let's make it 150. That's pretty good. And we'll slow down the rate. Oh, we should have made that a variable. That's actually firing the bullets. Oh, sorry, bullet timer. Ah, I should document some of these variables now. So the timer is used to determine how far apart the bullets are shot at when you hold down the fire key. That's right. Oh no, age is right. We updated the age, sorry. So we need to increase the bullet timer in order to slow down the rate at which they're shot out. And we did make that a variable. Okay. Bullet timer max. Game state. Bullet age max, yeah. Okay, timer max. So if we increase this, it should slow down the rate of fire, I believe. Let's try like 3. It's probably like really slow. Yeah, nice and slow. Ooh, there's a bug. So when I'm holding down the fire key. If I happen to collide with something, it skips over the game over screen. Something else kind of weird happening there. I think when it manages to skip over that screen, we're not resetting some state somewhere. And so the bullets continue firing. This is a pretty good strategy. should. There you go. Yeah, okay. It's a pretty rare bug. Pretty hard to get, but it's there. Okay, so game over scene. Let's update that. Fix that. This should also just check the game state fire pressed. Now, if I manage to collide with one of these while holding down fire, dang. There. Okay, cool. And now I have to actually like lift the key up and press it again to actually quit and go do that thing so that we don't accidentally skip over the game over screen. We're playing fast and loose and holding down the fire button. Sweet. That's kind of like 2 changes, but that's okay. We'll just call this add some gameplay tweaks. Bullet firing. Also fixed the game over screen. Button state check. Okay, that's good. Yeah. Sweet. Let's see, what else do we need to do? We could try the bug, the quit bug. Yeah. So for that, we're gonna have to reset the button state back to the initial button states. And we should reset the bullet timer. Okay. And I think that's good enough. I'll commit that. Wiring. 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 Okay, cool. That's done now too. Let's look at our to-do list. Okay, we have spawning off screen. That's actually done. Special case in collisions with bullets. When a bullet is outside of the player area, it shouldn't count towards collisions. I think that's true. Let's check if we fixed that already as well. Yeah, so there's this, in case you're just tuning in for the first time and you haven't really been following along, the way the play area works and the screen wrapping is that we have like this kind of outer border off screen where if we detect things, game objects are completely off the visible area of the screen and in this kind of border zone, then we transport them to the other side, and then they and set their velocity and everything so that they're in the right place, and it looks like they're wrapping around the screen. Right, so if you imagine the screen here, just draw a little screen. So everything inside this blue area here is the play area. And then we have this tiny little border around the edge. Near. Where if like a bullet or something is detected in here, then we flip it over to the other side and let it continue on its merry way. So then it looks like it's wrapping around. However, when we do our collision detection, and what we need to investigate and to make sure of is that we fix this, is that we were doing collision detection with bullets and asteroids in this zone. And so you could blow up an asteroid before it even has a chance to appear in the play area where the player can see it. Which leads to that effect where you can just kind of spray bullets everywhere and an asteroid will never get on screen, but you'll see your score go up. So we could probably tighten that up a little bit just by filtering out the collision checks if they're not visible. Unfortunately for you, if this is your first time tuning in, and maybe you're not even familiar with Haskell, our collision detection code is something. It's not the greatest, but it is what it is, and it works, which is good enough for me. All right, so here is probably where we need to check for it. And the reason why it's not so great is because like we're using recursion to like go through the list of bullets, and we're basically, let's not even use the word recursion. We're looping through the list of bullets and checking it against every other asteroid is what we're doing. We're just representing that loop as a recursion here, but they're basically the same thing. Well, at least you can convert one to the other, and they're not the same thing technically, but you can think of them that way because you can convert between the two. Depending on the way your language is implemented and stuff, they'll be obviously quite different. Or I shouldn't say obviously, but they'll be different in terms of like performance and whatnot, and different dimensions too. So anyway, that's neither here nor there. So what we need to do when we're checking is colliding is guarding it. Not only is the asteroid not dead, and the bullet is not dead, but that the should we check if the collision boxes are at least visible, or at least in the playing area? I think that might be the way to go. So we could check for collision with a big box, the viewable screen box, and reuse this is colliding box thing. function. We could do that. That might work. And we're basically checking 3 collisions. Or before we even get to is colliding, we could have a guard on here that's... We could update the guard here. And check the position of the asteroids and bullets. Or we could even maybe filter the whole list of bullets first before we fold over it. So we only get the visible ones. I don't know if we do a fold first on the bullets and compose and then pass that result of that fold, or the filter, if we do the filter first on bullets, and then we pass that filter to fold, if we will get any list fusion there. Because the thing I don't want to do, I prefer not to do, although it won't really matter a whole lot in this case. But basically, we don't want to traverse the structure twice. We can avoid it. And if we had to filter first and then do a fold, we might have to do that. But sometimes Haskell's pretty smart at, or GHC at least, is pretty smart at doing something called stream fusion or list fusion, where if you compose these list operations together, it can figure out what you're trying to do and do them and basically fuse things together. Something like that, you know? But it's tricky. It's tricky for me, at least. I don't know how to detect when it's actually doing that. We might be able to do like this. And we only check the visible bullets. And if we compose this way with these list operations, if they're fusible, then this should actually be like one simple operation, not two right? Is there, maybe I can Google this quickly and find out if that's true. Google fold L and filter stream fusion. Yeah, good old Haskell Stack Overflow. There's a whole blog post on it. It's inlining and inlineable and all that stuff. Cool. Good stuff about inlining. Specializing. Alright, so that's a whole bunch of stuff about specializing. Rewrite rules. Lets you rewrite certain things as in other ways. So before we start talking about fusion, so fusion is a technique that allows us to avoid constructing intermediate results when chaining operations of functions. Okay, that's what I'm talking about with like stream fusion and stuff, list fusion and stuff like that. Fusion without rewrite rules. Map and fold arg. You can rewrite the function differently. Using lists. Right. All right, so you actually get pretty fast operations for that structure when fusion kicks in. What do we need to make sure that we can to find out if our expression will fuse? Rewrite rules. So filter, okay, so it looks like we would have rules for combinations of functions. And certain combinations will work well. We'll get stream fusion and others won't. Okay, cool. So let's just write it the dumb way. And then we can check up on that at some point. Because we're almost out of time here. So that's a little bit about stream fusion. Not a whole lot, but that's a good blog post, actually. Mark Kaprov, tutorial / GHC optimization and fusion. Pasted in the chat for you. Okie doke. Let's do it. So we have filter is visible. We just have to write is visible. Undefined, blah, blah, blah. Okay, bullet to bool. So we want to check if the bullet, we want to check the bullet position. So we have v2 pos x and pos y. I'll pull out the pos X and pos Y parts. Oh, that's right. This might not work with filter because that's a deck, not a list. Oh, I don't think foldable has a filter, does it? And our deck. Our deck. Yeah, why would it? It wouldn't. Oh, it's traversable. It's not helpful. Is list. Yeah, we'd have to convert it to a list to do filter and get all that stuff. I forgot about that. Okay. So that's no bueno. We learned a lot though, but that is not the way to go. Okay, so instead of is visible, we'll just do that check on is colliding. No, we'll do it as a guard here. Is the bullet visible? Bullet list of asteroids that maybe have to like set. Or the input bullet. Final state of the input bullet. Okay. B, I think, is the bullet we're checking. Yeah. Yeah, B is the one we're checking. Yeah. Okay, bullet, the bool. Yeah, okay, I had it right already. That's fine. We just had to put it in different places. And there we go. And then V2, pause X, pause Y, bullet position. Okay. And so if X is greater than 0 and less than the width of our screen, pause X, and the width of our screen, and pause Y is greater than 0, and pause Y is less than the height of the screen. Now, the thing I just need to check is, do we have variables for that, or did I just leave it hard-coded? Playfield width and height, yeah, we left those there. Affordances. Nice. They might need some conversion, yeah. No, yeah, those are floats. We convert to px, truncate, posx. Just convert those all to p. There. Okay. That's a small thing. That'll be pretty difficult to test. On live game, okay, but we have tests for it. Let's give the context. When the bullet is not in the playfield, it should not count as a collision with an off playfield asteroid. It should not count in collision detection at all. Yeah. Okay, so our list of bullets. I'll just grab that from up here, modify it. Actually, we can do modify B here. From list, and we'll just do B where bullet position is equal to V2, and we'll make it like negative 0.2, negative 1, make it really obvious. And A's, we'll do the same thing. So we'll just make them collide. Asteroid position. And we'll even make them the same position. Okay. And we check the asteroid collisions, the A's and B's. This should be the empty result. So bullet and asteroid collisions, 0, empty and empty. Think that'll work. Let's test. Do that. Well, might not compile. We'll see. Well, it seems to be working, blinking. Okay. No, it didn't. Okay. These are legitimate type errors. Oh, B is not in scope. Why isn't it not in scope? Okay. It's in that context's scope. So we probably don't even need this setup here. Let's make this B's, and we'll make this ext.from list. And wrap this in a list. There we go. Make that A's. Okay. Grab you. There. Beep, 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 beep. And then we just change the positions. Okay. Now this test should pass when we run it. Failures. Let's see. Missing field in record construction asteroid size. Oops. And it's probably the other one. Yeah. Yeah, okay. We just changed the asteroid type. We didn't update the tests. Of course. That's just how it goes sometimes. Asteroid size. We'll make it a large. Why not? Or big, sorry. Big. And the other one should be that too, maybe. Okay. Terminal, come back to me. There we go. Now it will compile and run and work and be successful. Green test, let's go. Oh! Interesting, okay. That's an interesting result. Okay. That means it probably isn't quite working just yet. But we are out of time on the stream. So we'll make this test pass next week. And that will be fun. And then we'll get sound working as well. As promised. So let's review what we've got so far. Okay, we'll stash these as well. Fix collision edge case. Okay, so we'll push what we have that's working to master. If you are just tuning in for the first time, of course, the code that you've seen tonight is all available on GitHub. Here at Agent Ultra / Asteroids. That's me. I'm Agent Ultra. And I usually do these streams on Tuesday evenings at about 10 after 8 in the Eastern Standard or Eastern Daylight Time Zone, depending on the time of the year. Glad that's over with. And you can follow me, of course, on the socials and on here as Agent Ultra. Just give me that follow and you'll get notified if you have all the settings set up on Twitch. If you're watching on YouTube because you're in a different time zone altogether, you know what to do there as well to get the updates when I upload the videos there to my YouTube channel. Of course, I'm also on the Fediverse at types.pl /Agent Ultra, so you can follow me there. And on GitHub, follow me there, you know, all the deals. Thanks for tuning in this week, and hopefully we'll see you next week. May all your types check and may your monads be free, and usually I say that backwards. And have a good one. Take care.